We're focusing on 2.4 notes today, which is focusing on the question, how are solutions of an equation of the form y equals mx plus b related to the graph and the table for the same relationship? So now we are here looking at this graph. They gave us our graph. They gave us our equation. And in the scenario, it says, look again at Elena's pledge for the problem 1.3. Suppose A represents the amount raised in dollars, and D represents the distance walked in kilometers. You can express this plan with the equation A equals 5 plus 0.5D, right? So they gave us our equation. They even plotted it on a graph for us, so all we have to do is look at it and answer the questions. So in the first question, explain why the point 14, 12 is on the graph of Elena's plan. Who was able to determine, Peyton, how can you explain why it's on the graph? How do you know it's on the graph? Yeah, what do you mean by match up in the graph? It goes through this line. So we look at where that point lies on our graph, 14, 12. Does that coordinate, 14, 12, go through our line? Does our line go through that point? Yeah, it does. So we can say that the point on the graph the point, we should say, is on the graph because it is a solution of her equation. What they mean by solution is that it's a point, it's a coordinate on her line, which means it has to be a solution in her equation. So if she walks, this is basically saying if she walks 14 kilometers, she will earn $12. That's how much she'll earn. That's basically what that's saying. Because we know our X is the distance walked, and we know our Y is the dollars, the amount of money earned. Down here it says, write a question you can answer by location. This is written. Write a question you can answer by location this point. Locating, yep. It's written wrong. I'm going to have to change that. By locating this point. So we want to find a question, create a question about that point, 14, 12. What's a question we can say? Any kind of question. There's not a wrong here. Any type of question we want. Lily?
How much money will she earn?
Okay. We can say that. If she walks 18 kilometers, how much money will she earn? That's a good one. Okay, I like that one, Lily. Next question, it says, how can you use the equation for Elena's pledge to check the answer to the question you made up? Well, how can we use that equation that they told us at the front, which I'm going to rewrite it right here so we can see it since I scrolled down. The equation was A equals 5 plus 0.5D. So based on the question that Lily created for us, she said, hey, we know 18 kilometers, but what is the, what is the money? So how can we use our equation to determine the money? That's what we want to find. So how can we use that equation to help us answer this, Philip? What does A represent in our equation, Phil? The cost. Right, that's right. And what about our D? What's that mean? Distance. Yeah. Perfect. So now that you know what those two mean, and now that Lily told us that there's 18 kilometers, can you tell me, can you solve for our money by using that equation? Yeah. We could easily put in 5 plus 0.5, because we know that's the equation, and plug in 18 for our distance, because she told us it's 18. So when we simplify this, we can find our A. We don't have to. It's just asking us, how can you do it? So you can use Elena's equation. You can use Elena's equation by plugging in her distance to solve the total cost. Right? That's what Philip and I were just talking about. Blake? So we're going to keep going. It says, how can you use a graph to find the number of kilometers? We want to find our kilometers. I always underline this stuff so I know what I need. And important information. Because once you go on to more of story problems, it's going to be easier to pull out the information you need. So it says, how can you use a graph to find the number of kilometers that Elena walks if the sponsor donates $17? It says they want us to look at the graph. How can we do that by looking at the graph? Before we did it looking at the equation and creating it with the equation, but Gracie, how can I do it now looking at a graph? If they tell us $17, what's the deficit? What's the distance? I'll go up to my graph. They say it's $17. So that's going to be probably somewhere, I'll do it in a different color. It's going to be somewhere probably up here, right? How can I find what my money is? What my distance is? Look at this graph. Look up here. So this is the distance. This is the line they created using the equation. So if this is 17, it's got to be somewhere on our line. They just didn't specifically note it like this and like this did. So if we go all the way across like this, can we eventually run into our line to determine the amount of money at $17? Yeah. So what we can say down here is that we can find $17 on the y-axis because our y-axis is representing our money, and see what the x value is. Because they created the line, we just got to figure out if we go across where it crosses into our actual line, right? Does that make sense, Gracie? Okay. So if we keep going, it says, how could you use an equation to answer this question? So now we just went and did it answer the question by using the graph. But now they're saying, okay, you know the equation. I'll write it again. A equals 5 plus 0.5d. Using that equation, how can you determine what the distance is? Talk with your shoulder partners for about a minute. All right, we should be coming back together now. Ava Dummers, what did you and your shoulder partner say about how you could use the equation to answer this question? Yep. Perfect. Good job. So I used a vocabulary word, Ava. Instead of plugging in, we can always say substitute. So I can substitute 17 in for A and then solve for what our D is by using the equation. So it's exactly the same. I just wanted to let you know. It's exactly how we could do it. On the back, it says problem 2.4. Consider the following pledge plans. In each equation, Y is the amount pledged. Let me go to the next page. Right here. Okay, it says Y is the amount pledged in dollars by each sponsor, and X is the distance walked in kilometers. So we have plan 1, plan 2, and plan 3, and they created equations for us. So we're going to be looking at those equations. In part A, it says for each pledge plan, explain what information the equation gives you about the pledge. So in plan 1, what is it telling you? We got to break it apart. That's what they're asking us to do. They want us to break apart what each variable and number means in plan 1. Becky, help me with the first part of it. We have 5x. What does that really mean? What's my x mean again? We'll do that one. Distance walked. Okay, so what does the 5 mean? It's in money. So we can say the spot. Yes. So the sponsor donates how much money per kilometer? Becky? Okay, exactly. Donates $5 per kilometer, however many kilometers that is for X. And then we also know there is a $3 value that is given back because it says minus 3. So we're giving that back to them. We're subtracting it out of what our total is going to be. So there is a $3 value that is given back, or they possibly spent it on the t-shirts that they bought. Remember last week we were saying that they all bought t-shirts to walk, so then they knew what team they were on or who they were running or walking for. They could have possibly spent that money, that $3, on a t-shirt, or they could have just refunded people possibly. We don't know. They didn't tell us. We just know it's $3. Okay, thank you, Becky. So on plan 2, Gavin, help me break apart plan 2. All right, Gavin, what was that? We can say the sponsors. Let's start with that, just like the last one. What do they do?
Negative x.
Mm-hmm.
So
Negative x.
are we going to assume that x is a 1?
Yeah, you're going to assume that x is there's a 1 in front of that x. I think that's a great assumption. What about that plus 6? Before we had a minus 3, which meant we were giving back $3. What's it mean when there's a plus 6?
We're getting $6.
We're receiving $6. Yeah. So the sponsors give $6. And then what did you say about giving back? About our negative x? What's that really mean?
-1.
Yeah, so maybe we're giving back $1. Because our numbers are in dollars. So the sponsors give us $6. And then you give back $1 for every kilometer walked. However many kilometers they walk, we have to give back that many. So if they walk 2 kilometers, we're giving back $2. All we're doing is breaking apart, Lily, that Y that you were asking about. That's basically like the total money that they're going to have at the end. So it's going to be really the same for all of them. That's why we're just breaking apart the other side. We don't have to break it apart right now. We're just going to be focusing on breaking apart the other side. Aiden, the last one, point 3. This one's a little trickier. It says y equals 2. Y equals 2. What does that really mean? Who gets $2? Yeah, the sponsor. Good job. The sponsors give $2 no matter what. No matter how far they walk. Whether they put their shoes on and run 2 kilometers or don't even leave their couch. If they signed up, they're given $2. In question 2, now we're creating a table for all of these plans. We're basically doing the same thing 3 times because we have 3 different equations. So it says for each plan, make a table of values of x and y. Use values of x from -5 to 5. So they gave us that. Our x values range from -5 all the way to the right, which is a 5. I'm missing some lines in here. Are you guys missing some on your plate? Okay, let me fix mine then. Okay, I think that's it. So there's our table. They created everything for us, and we basically just had to fill in our y's. So when they have -5 for x, here's my equation for this plan 1, y equals 5x minus 3. How can I determine what my y is going to be if they told me my x? How am I going to determine that? Eliana? If they tell me x equals -5, how can I find my y? I'm sorry? Yeah. I'm going to substitute. I'm going to plug in my -5 into where our x is in the equation. So, if I have 5 times, right now we have -5. 5 times -5 gives you what? 5 times. We're not adding. So it's not going to be, that it'd be 0 if we are adding. Since they're connected to each other, since they're sitting right next to each other, our 5 and our x, and there's no signs in between it, that means they're multiplying those together. So if I have 5 times x, that's like 5 times a -5, which is what? What's 5 times 5 first? 25. And then a positive times a negative makes it a negative. So we have a -25. Now we got to subtract 3 from that. So if I have a -25 and I'm subtracting 3 from my -25, that means I'm getting further away from my 0. When I subtract, if I have a number line, like right here, I'll make a number line. Here's -25, -26, -27, 28. We'll go a couple over here too. Right? This is my number line in the negatives. And if I'm at -25 already, because we calculated that, and I got to subtract -3, I'm going to keep going this way. 3. Not going to go towards 0. I'm going to go more negative. So if I were to subtract 3, what would it be then? Exactly, -28. And I'm going to do the same thing for the rest of them. So 5 times -4 gives me what? -20, because 5 times 4 is 20, and a negative times a positive is a negative. So that's -20, and then -3, -23. Awesome, guys. Same thing with -3. 5 times -3, Becky? Yeah, 5 times -3 is what? 15, and I'm going to subtract 3. -18 then. So, work on the rest of this, just this table for plan 1 with your face partners, and we'll come back together and fill in the rest. Okay, we're coming back together. Anthony, can you help me fill in the rest of this, please? Okay. What did you get for the -2 portion? We did -5, -4, -3. What is -2? -13. Then what? -8. Awesome. Perfect. Yeah, because it's 0 times 5, which gives you 0. And then 0 minus 3 is negative 3. Okay. Yep, keep going. 2, 7, 12, 17, 22. Awesome. Hand on your head if you got those. Hand on your head if you got all of those numbers in your table. Okay. Hand on your nose if you have a question about those. If you have a question. No questions as to how we did those? Okay. So we're going to keep going for plan 2. Plan 2, our equation is y equals negative x plus 6. That's the equation we're going to be looking at, and we're going to be filling in the table just like we did for plan 1. So if I plug in, this one gets a little tricky because there's that negative there. A negative 5 for x. It's really saying a negative 1 times a negative 5, like that. So a negative times a negative is what? A positive. And then this is a negative 1. So 1 times 5 is what? So we're given a 5 here. And then 5 plus 6 gives you 11. Negative 1. That's like a negative 1, right? Because our negative x really means there's a negative 1 there. So negative 1 multiplied together with a negative 5 gives you a positive 5. So then we're given 5 plus 6 because we got to add it to our 6. So 5 plus 6 gives you 11. Any questions as to how we got that? No? Okay, let's go on throughout the negatives then. Negative 4 then. Negative 4 times negative 1 gives you what? 4 plus 6? 10. Awesome. Sophia, what about the next one? Negative 3. 9. How did you get that? Negative 3 times negative 1, right? And then you added that. What did you get for that? Negative 3 times negative 1 gave you a positive. Negative 3 times negative 1. Yep, 3. And then you're adding that to 6, right? And you got 9. Awesome. And then if we keep going with negative 2, we get 8. Negative 1 gives us 7. 0, it's negative 1 times 0. That gives you 0. And you still have that plus 6, so you got to add 6 to 0 to get 6. Now we're in the positive, so it's looking a little nicer. 1 times a negative 1 gives you a negative 1 plus a 6, 5. We can kind of see a pattern going here, can't we? So 2 times a negative 1 gives you a negative 2. Negative 2 plus a 4 gives you 4. If we keep going, we have 3, 2, and then 1. Becky, did you have a question? Okay. Oh, okay. Okay. Questions as to how we got plan 2? No? Okay. Now on to plan 3. Plan 3 gives us the equation as y equals 2. So, how am I going to solve this plan? Exactly, Stephanie. Doesn't matter what our x is, it's always 2. Always. So I can plug in, let me get a marker. 2 for everything. 2, 2, 2, 2, 2, all the way across. Can I see your book for a minute? Any questions as to how we got that? Yeah. Any questions? Okay, so if I go to our book and go to our 2.4, let me find it in the book. What page is it on? 2.4 in the book. They show us different ways to graph. We're basically using the table that we just created up above to create 3 different graphs now. So if I create this graph for plan 1 over here on the left, I'm going to create my y-axis. And I'm going to put my x-axis about here. And all I'm going to do is plot the points that we just created in the table. So I'm going to make this, I'm going to go by twos. 2, I'm going to skip lines. 4, 6, 8. And then over here, 2, positive 2, 4, 6, 8, 10. And then the same thing, when I go up, I'll skip a line and go by 5. 5, 10, 15, 20. I'm going to decide that on the numbers I'm given. I'm given some big numbers in the 20. So if I go by ones, those numbers are going to be way off the graph. Oops. 5, 10. Okay. About that. Right around there. So now I'm going to plot it at negative 5 for x. Negative 5 for x. I am at a negative 28, which is going to be about down here. I don't think I can go any lower on my page. Oh, I can a little bit. It's going to be about here. And then negative 4. Where am I at negative 4? About 23. And then negative 3, I'm at 18. Negative 2, I'm at 13. See how each point that we have on our table, I'm looking at our table when I go through this. It's going to be about here. 1. Now I'm in the positives. My x is at 1. My y is at 2. X is at 2. My y is at 7. I see a pattern coming here. What kind of line is this? A linear line, exactly. A linear line. Okay, so if I use all of my points that I just plotted, and let's see how straight I made this. It's almost there. About straight right there. That's my line. That's how I would create it on a graph now that I was given my table. So we're going to do the same thing for plan 2. Plan 2, I'm given a little bit smaller of numbers, so I can go by ones. I have negative 1, negative 2, negative 3, negative 4, negative 5. Okay, then I have 1, 2, 5. 1, 2, 3, 4, 5. So I just went by ones this time. Now, based on the Plan 2 table that we have, I can go up a little bit. Based on the Plan 2 table, we should be able to plot all of these. I think I might have one, maybe 2 off the graph a little bit, but we'll just try to plot it as best as we can. So for negative 5 is x, which would be way over here on the left. I'm at positive 11, which, yeah, that one's going to be the one off the graph. And then negative 4 is at 10, a little off the graph still. Negative 3 is at 9. This one should be here, and then this one should be there. Negative 2, I'm at 8. Negative 1, I'm at 7. 0, I'm at 6. Awesome, I'm coming on the graph now. I'm at 5. 2, I'm at 4. 3, I'm at 3. 4, I'm at 2. And 5, I'm at 1. So, look at Plan 3 and start plotting your points for Plan 3 on your graph. Okay, while you guys are doing your Plan 3, I'm also going to start creating my graph. Okay. Hand on your head if your third plan looks just like my graph that I just created. If I can get this line straight. Hand on your head. So our x values are different because they range from -1 to +1. So all the way over here I have 1, 2, 3, 4, or -5 to +5, I'm sorry. So there's all my points. But we knew they were only at 2 on the y-axis, so it's just going to be a straight line. They're all linear, aren't they? Okay, I'll give you about 2 minutes to finish creating these graphs. Any questions as to how any of these three are created or why we did something? Okay, so we're going to finish our notes here. We're going to pick up tomorrow by looking more into these graphs and looking more into our table that we just created. There's no homework today. We'll finish these tomorrow and get assigned homework tomorrow.